Okay, sorry about that. My battery died mid-problem. So we are trying to figure out the total probability, right, that we might roll the sum of 7 or 11 on two number cubes. So we know that there are 36 possible outcomes, total possible outcomes, and we're just now thinking through how many of them might give us a sum of 7. And so we thought, well, 1 and 6, or we could roll a 6 and a 1, we could roll a 2 and a 5, or a 5 and a 2, a 3 and a 4, or a 4 and a 3, and that's as many as I can think of that'll give us a sum of 7. So that's a total probability. There's 6 possibilities out of 36 possible outcomes for a sum of 7. Let's think our way through the sum of 11. This one's going to be less possibilities, right? Because I would have to roll to get an 11. I either have to roll a 5 and a 6 or a 6 and a 5. That's all I got. So the total the probability of rolling a sum of 11 is 2 out of 36. And the way that I figure out the total the probability of rolling one or the other is by adding those two probabilities together. And I end up with 8 out of 36 chances. Now if I do that division, I'm going to end up with, to get a percent chance, I'm going to end up with, right, 0.22 or a 22% chance, approximately. Now if we roll this thing 100 times, that's just on a single roll. So if I roll this, if I multiply this by 100 rolls, approximately, right, predict the number of times that either a sum of 7 or 11 is going to be rolled. The answer, if I multiply 0.22 by 100, is 22. Okay, 22 times. That's my answer. All right, 3 more problems left to go in this lesson. 28, 29, and 30. So let's make our way through those. Which one of the following situations describes mutually exclusive events? All right, for this one, we're just going to have a letter for our answer. So we've got to think through this. So mutually exclusive events means that they can't happen at the same time. So which one of these scenarios describes an event where the outcomes cannot happen at the same time? Let's look at them one at a time. Rolling doubles or a sum of 4 with 2 number cubes. No, that can happen at the same time. I could get 2 2s, right? And that would be a double and a 4. So that one's out. Choosing an odd number or a multiple of 3. Well, for heaven's sake, what if I get a 3? Then I have also an odd number, so that one's out. Letter C, tossing a coin heads up or rolling a 2 with a number cube. Well, I can get those at the same time if I toss the coin and the number cube, right? Same time. All right, plus it says or right there. How about this one? Rolling 2 5s or a sum of 12 with 2 number cubes. That is the one, isn't it, gang? Because if I roll 2 5s, I have a sum of 10. So I can't roll 2 5s or a sum of 12 at the same time. That's it. That's the mutually exclusive event. Okay, so that's letter D. Number 29. On a winter day in Maine, there was a 30% chance of freezing rain. That sounds horrible. 45% chance of only rain. And a 25% chance of only snow. I am glad I do not live in Maine. What was the chance of getting only freezing rain or snow? Well, when I've got probabilities like this and I want to know this or this, then I add those two probabilities together. In this case, they're already in percentages, so I can add the percentages together, right? So if I get 30%, this guy right here, plus 25%, then the chance of getting one of these two is 55%. Hopefully we didn't overthink that too much. And there's a 55% chance of getting only freezing rain or snow. Last problem, number 30. Given two possible events, A and B, will the probability of either A or B occurring be higher if they are inclusive events or mutually exclusive events? Okay, so if we want to know the probability of A or B, if they're mutually exclusive, that means they can't happen at the same time. Okay, then you have a 50-50 chance. 50%, A is 50%, B is 50%. Right? If they're inclusive, meaning I could possibly get them at the same time, it's going to be less because I would have the 50% chance, right, for A, the 50% chance for B, and I'd have to subtract out the percentage that I might get A and B, because inclusive means that they can happen at the same time. So this one is going to require subtraction from one of these probabilities. So it's automatically going to be less. So reasoning my way through that, the probability is going to be higher. Okay. I'll just write this down with words. The probability will be higher if A and B are mutually exclusive, meaning you can only get one or the other. Okay, guys, lesson 69 is next, and I will walk you through the homework after we do the lesson. See you then.